Torsion in shafts refers to the twisting deformation of a shaft caused by an applied torque, leading to shear stresses and strains within the shaft's material. This occurs when opposing torques are applied at the shaft's ends, causing it to rotate about its axis. Some basic terms related with shafts and torsion are explained below. Torque, a twisting force applied to a shaft, causing it to rotate. Shaft, a cylindrical member used to transmit power and rotational motion. Shear stress, internal stress within the shaft caused by the twisting force, highest at the outer surface and zero at the center. Angle of twist, the amount of rotation or twist experienced by the shaft under the applied torque. Torsional rigidity, a shaft's resistance to twisting, determined by its material properties and cross-sectional geometry. Polar moment of inertia, a geometric property of a shaft's cross-section that indicates its resistance to twisting. When a torque is applied to a shaft, it creates a twisting moment, causing the shaft to rotate. This twisting force induces shear stresses within the shaft, which are greatest at the outer surface and decrease towards the center. The shaft deforms, twisting or rotating about its axis, resulting in an angle of twist. Some factors like rigidity, shape, size, and dimensions affects torsion. The material shear modulus, G, and torsional rigidity influence the shaft's resistance to twisting. The shape and dimensions of the shaft's cross-section affect its resistance to torsion. The magnitude of the applied torque determines the shear stresses and angle of twist. The shaft is considered to be in pure torsion if it is subject to two opposing turning moments. This causes the shaft to shear off at every perpendicular cross-section. This moment or torsion will bend the circular shafts without affecting the shaft's cross-section. Torsion plays an important role in car suspension system. In a car suspension system, torsion refers to the twisting action of a torsion bar or torsion beam, which functions as a spring to absorb road shocks and provide a controlled ride height. Torsion bars and beams are commonly used in the suspension of vehicles, particularly in the rear suspension. Torsion, in the context of a rotating wheel, refers to the twisting or bending stress experienced by the wheel's structure when a torque, a twisting force, is applied. This force, often resulting from friction or applied braking, can cause the wheel's hub or axle to twist, potentially leading to deformation or failure if the applied torque exceeds the wheel's structural capacity. When a gear shaft is subjected to a torque, a twisting force, it experiences torsional stress. This stress is not uniform across the shaft's cross-section. It's highest at the outer surface and zero at the center. Torque is the measure of twisting force, calculated as the product of circumferential force multiplied by the radius of the gear. This means that bigger gears will have more torque than smaller gears because of the larger radii of the gears. Gearboxes have a torsional stiffness, which is a measure of how much the shaft resists twisting under a load. The torsional stiffness of a gearbox is influenced by the deflections of bearings, shafts, gears, and the gearbox housing. Torsional vibrations can occur in power transmission systems, especially when using rotating shafts or couplings. These vibrations can be detrimental and lead to failure if not controlled. When designing gears, it's crucial to consider the torsional stresses and deflections to ensure the gear system can withstand the applied loads without failing. Repeated torsional loads can lead to fatigue failure in gears and shafts. Proper material selection and design practices are necessary to mitigate this risk. In internal combustion engines, torsion refers to the twisting force, or torque, generated by the combustion process and applied to the crankshaft. This torque is a crucial aspect of how the engine produces power, converting the reciprocating motion of the pistons into the rotational motion needed to drive a vehicle. Torsional vibrations, a form of these twisting forces, can also arise in the crankshaft and other engine components. Crankshafts, present in internal combustion engines, are mechanical parts subject to torsion and bending that vary over time and, if the forcing is close to one of the natural frequencies of the system, they can encounter problems of torsional oscillations. A spark ignition (SI) engine produces torque by controlling the net airflow into the engine using throttle, turbocharger wastegate, and cam phasing actuators. 1 Newton meter, Nm of torque is the torque produced by a force of 1 Newton applied at a perpendicular distance of 1 meter from the pivot point. Torsion, or twisting force, plays a role in braking systems, particularly in the context of modeling and understanding the dynamics of a train braking system. It's important to consider torsion, especially when simulating the braking process, as it can affect the system's stability and response. Researchers use mathematical models to simulate braking systems, and these models often incorporate the effects of torsion, particularly when studying the interaction between the disc pad and wheel rail subsystems, the friction between the brake pads and the disc, and the adhesion between the wheel and the rail, are key factors in the braking process. These factors, along with torsional vibrations, can impact the overall stability of the braking system. Models used to simulate braking systems often include torsional elements to accurately represent the dynamics of the system, including the effects of wheel rail adhesion and friction. Torsion plays a role in several mechanisms within a lathe, primarily related to the transmission of power and movement. Specifically, torsion is used in picking mechanisms, found in some weaving machines, although not directly in lathes, to generate the force for picking the shuttle, and it's also relevant in the overall drive and feed mechanisms of lathes. Torsion in a steering mechanism refers to the twisting force applied to a torsion bar, which is a key component in some power steering systems. This torsion bar is connected to the steering wheel and transmits the driver's turning effort to the steering gear, ultimately steering the vehicle's wheels. In some systems, the amount of torsion in the bar is used to adjust the power steering assistance.